All right, now I want everyone to please close your eyes for a second. Now for a moment, you're in the dark, unable to observe the world around you. Open them. Just like a camera, your eyes are taking in light, information even, about the world around you. Now take a look at the 4 shades of green, discrete green, taken from Charleston, South Carolina waterways. If your neighbor turned any of these shades of green, you'd think they're about to be sick, and you would sound the alarm. Watch out! Well, my thesis used a similar observational technique looking at Charleston waterways. Now, traditional water quality monitoring is limited because it is discrete. We collect 1 bottle of water at a time. But here, I'm using Spycraft, algae satellites in space. Charleston, South Carolina is under incredible pressure because we have 30 new people moving to this area each day. That increases the amount of runoff, which carries nutrients, including fertilizer and animal waste, even septic tank waste into our environment. Now, this stimulates microbes, and as they grow, they change the color of the water. And so what I did was I went out into the field with a team of volunteers. This is actually a selfie by satellite. You can see a single pixel of white at the top there. That's me and my team, collecting 200 bottles of water across the Charleston harbor. Now what we did was we worked with the Sentinel-2A and B, Earth-observing satellites, which are super sensitive. They scan the Earth and come over Charleston every 5 days. So what I was able to do was, for an area about the size of your average elementary school classroom, I knew how much water, how much algae was present in the water, and the amount of brightness from the different colors of the rainbow coming off of that area. And I learned that the water in Charleston is complex. It's many different shades of green and brown and yellow. So I was able to develop an algorithm, a math equation, if you will, which paired the two. And I found that because the water is so complex, we actually need to use multiple colors of the rainbow, not just green, but red and blue to describe what's happening in this environment. So through my work, I've democratized water quality monitoring. Now, instead of going out to the field and collecting 1 sample of water over and over and over again, and using that to figure out if our water is sick, we can actually use the web browser on your smartphone and publicly available satellite images, in addition to my thesis research, to figure out if the water in Charleston is sick. Now that's 400 square miles of water, which we can observe much easier. It's much more cost effective, and it's something that we can all do. So I want to empower you to be scientists and understand what's happening in the world around us using my thesis. Thank you.